Hello, my name is Matt Kixmoeller. I'm the VP of Products here at Pure Storage. And welcome to today's Pure Storage Architecture Chalk Talk. In this session, we're going to go through a little bit of the high availability and resiliency strategy within the Pure Storage FlashArray. In previous talks, we've gone through the software architecture and the anatomy of an I/O, how I/O is actually stored within the system. So if you haven't seen those talks, you might want to look at that one first. So a little bit of an overview on the background of the hardware of the FlashArray and how that lends to high availability. First of all, the FlashArray is constructed with dual active-active controllers and expansion shelves. The controllers do the processing and the expansion shelves do the storage with the SSDs. Now, the active-active controllers are interconnected with dual redundant InfiniBand links that run at 40 gigabit a second. This allows for high-speed transactions and communication between the two controllers. It also allows us to have the front-end ports on the FlashArray, which are Fiber Channel or Ethernet, to be connected to hosts redundantly, and allows you to fundamentally send I/O to any port within the FlashArray. All the LUNs are available on all the ports, and our default configuration is just to have you round robin across all the ports available in the array on both controllers. Now, the controllers themselves are connected to the storage shelves via 6 gig SAS. And the 6 gig redundant SAS allows for expandability, and it allows for each of the controllers to be hardwired to each of the both NVRAM devices and SSDs within the system. This allows for obviously any of the paths on the back end to fail and any of the controllers to fail and still have the other controller have access to all the storage. And finally, one of the other unique characteristics of the FlashArray is that the NVRAM devices are actually stored within the storage shelves. This allows us to persist in-flight data in case of a power loss, but it makes our high availability and failover dramatically simplified compared to a traditional array, because both controllers see the NVRAM devices that are redundant down in the system. And so this allows a takeover to be very simple. It also allows each of our controllers to be completely stateless. So if you happen to have a controller failure, you can unplug the old controller, bring a new one in, boot it up, and it adds itself to the system. All right, let's look a little bit at the resiliency around drive loss. So all of the array is protected through a unique form of RAID that we call RAID 3D, which is a special form of RAID we designed to be unique to the characteristics and failure modes of Flash. At a high level, and we talked about this in the last talk, all the data that comes into the system that is ever persisted down to the Flash is done so in segments. And so the important thing to realize first off about our RAID is it's done based on write segments. It's not done based on disks. So as data comes in, we fill up a write segment, we calculate its parity, and then we select where to put it down on the Flash. We write it down to the Flash, and we do so in a pseudo-random algorithm. So what that means is over time, you'll have a wide distribution of all data across all eligible SSDs in the system. And that massive parallelization leads to very consistent performance. And it also means that if you lose a single disk in the system, you won't have a performance hiccup because there's such a wide spread of data across the system. So when a disk is lost, let's go ahead and say that this disk, for example, fails. We don't bother trying to replace it. We basically say, okay, we're going to assume if this is a system with, let's say, 100 SSDs, that disk is just going away. And going forward, we're only going to have a 99 drive system. We also don't bother trying to rebuild that disk. We just look at it and say, okay, of all the segments that we've written, which of them are now one level down parity, because every segment is at least dual parity, because of that drive loss. And so in this case, both the red segment and the orange segment were there. So what we'll do is we'll go through and we'll choose to optimize those red and orange segments. We'll read them into our system. We'll look for data we don't need anymore because it's been overwritten. And the unique data we want to keep, we'll go ahead and put into a new write segment and write it across the array as a completely fresh segment. Of course, only utilizing the drives that are left. And so both, in this case, the red and the orange segment would be rebuilt. And what you'll have is in the order of 10, 20 odd minutes, depending on how full your array is, your array will be completely back to perfect parity, and it'll just be 1% smaller because of that one drive loss. Now, you can continue operating like this until your next outage window, and forever, in fact, because your array is back to perfect parity. And if you do choose to replace that drive, you can slot in a new one, and as soon as the system recognizes that drive, the next time we do a segment flush down to the Flash, we'll start using it as a normal member in the system, and the data will expand over it. A very similar thing happens when you add a new whole storage shelf to the system. Basically, we'll realize there's a new set of, in that case, 22 SSDs, And in the background, immediately segments will start using those SSDs as members. And in the background, our optimization processes during their garbage collection will start moving data over there. And within a few days, you'll have a completely balanced array. Hopefully that gives you a bit of a sense for the high availability architecture of the FlashArray. We designed the FlashArray from the ground up with no single point of failure and to deliver very, very consistent performance, even in the face of multiple failures. We walked through here what happened with one failure, but you can lose 2 drives at any point in time. After that's been rehealed, you can lose 2 more, and you can continue to keep losing drives as the system reheals itself. Thanks, and I hope you join us for future sessions in the Pure Storage Architecture Chalk Talk.